Now we look at exercise sheet 4, question 2. So the question here is you're given a function y equals x cubed minus 12x plus 20, but the domain here is restricted to x between minus 3 and 5, and we're asked to find the greatest and least values of the function. So since we have a finite domain here, there must be a greatest and a least value of y. So this greatest and least value will be either at a stationary point or at one of the endpoints. So we start off looking for stationary points. To do that, we find dy dx, which is 3x squared minus 12, and we let that equal to 0. So that gives us 3x squared is equal to 12, or x squared is equal to 4, or x is equal to plus or minus 2. So x squared equal to 4 gives us two solutions for x, plus 2 and minus 2. So x is equal to 2 gives me y equal to 2 cubed minus 12 times 2 plus 20 is equal to 4. X equal to minus 2 gives me y is equal to minus 2 cubed minus 12 times minus 2 plus 20 is equal to 36. So those two stationary points are candidates for the absolute max or absolute minimum, or the least and greatest values of that function. The other two possibilities are the endpoints. So the endpoints of my interval are x is equal to minus 3. So that will give me y equal to minus 3 cubed minus 12 times minus 3 plus 20 is equal to 29. My other endpoint was x equal to 5. So that will give me y is equal to 5 cubed minus 12 times 5 plus 20 is equal to 85. So I have 4 candidates now for y values that could be the greatest or least values for this function, because the greatest and least values have to occur either at an endpoint or at a stationary point. So my 4 values are 4, 36, 29 and 85. So looking at them, I can say the max value is 85 and the minimum value is 4. And that's the answer. Those are the least and greatest values of that function on that interval. Question 3 asks, find two numbers whose sum is 6 and whose product is as large as possible. Right, I'm going to call the first number x. And once I've picked one number, well then the other one is determined because I have to add up to 6. So I'll call the other one a. And we'll say x plus a is equal to 6. So that means that a is equal to 6 minus x. So the two numbers here are going to be x and 6 minus x. And the question is to make the product as large as possible. So what I'm going to do is I'll write a function for the product in terms of x and I'll maximize it. So let's say the product is going to be y and it's equal to x times 6 minus x, or equal to 6x minus x squared. So again, my two numbers, I called the first one x, the second one then has to be 6 minus x, because they must add up to 6. Y is the product of the two, so y is equal to, in the end, 6x minus x squared. So I've written a function for the product in terms of one of my two numbers. So what I'll do now is I'll find the maximum value of that function and I'll see what value of x gives me a maximum. To do that, I'll get dy dx. That's equal to 6 minus 2x. Now my maximum is going to be a stationary point. So that's where dy dx is equal to 0. So 6 minus 2x is equal to 0. So at the stationary point, minus 2x is equal to minus 6, which means that x is equal to 3. So that's my only stationary point. So let's see, is that a maximum? We do the second derivative test. The second derivative, d2y dx squared, is the derivative of the first derivative, and it's minus 2. So that's less than 0. So the second derivative is negative everywhere, so it must be negative at my stationary point. So that means that x is equal to 3 is a local maximum. So at x is equal to 3, y is equal to 3 times 6 minus 3 is equal to 3 times 3 is equal to 9. So the answer I'm getting for this local max is that both numbers are 3. They add up to 6, and their product is a local maximum of that function. Now, we also have that there's only one stationary point. So if there's only one stationary point and it's a local maximum, well, the function can't turn around anywhere to come back up to that maximum, so it must be the greatest value of the function anywhere. So the largest product we can make is 9, and the two numbers that give it are 3 and 3. So that's the two numbers that add up to 6 and gives the largest possible product, is 3 and 3. You split it down the middle. Now that's probably not a great surprise to anyone, but this is a proof of that using calculus. And some of these more complicated problems later, we'll be able to work out maxima and minima where the answer isn't obvious.